electric current in conductors. Now this is the first basic of your current electricity. Actually, what constitute current in a conductor? You consider a conductor. You first you consider a conductor without the battery. Now you know conductor consists of atoms. Which consists of electrons. Now these electrons will be in motion. These are the free electrons inside the conductor. They will be in motion from one point to the another point due to the thermal energy they are having, due to the room temperature or due to the what we say kinetic energy, they are having. These electrons will be in motion. These electrons will be in motion throughout the conductor. But actually, when few electrons move from this end to this end, then will be few electrons moving from this end to this end. They will be in random motion. They are not, all the electrons are not moving in one direction. They will be in random motion. Suppose few electrons move from this end to this end, the same number of electrons will move from this end to this end. Then there is no net flow of charge. From one point to the another point. There is no net flow of charge from one point to the another point. Hence, it will not constitute any current. No current. Because to have the current through a conductor, there must be a net flow of charge. There must be a net flow of charge from one end to the other end. You may ask me a question, what does that mean, the net flow of charge? At least some charge should move from one end to the other end. That is not happening here. The reason is that as many electrons flow from this end to that end, few electrons move from that end to this end, the flow of charge becomes equal. Hence, there is no net flow of charge. Even though electrons collide with the atoms, their velocity does not increase, only direction changes. The direction of the electrons when they collide, the direction changes, but velocity does not change. Value of velocity, only direction changes. Direction of the movement of the electron changes. This is why when you take an ordinary conductor, even though it contains so many free electrons in it, it does not actually have the current. So then what we need to do to have the current? We need to apply the potential difference between the ends of the conductor now. Without the potential difference, we will not get the current. Now for just now, you know, if you take a conductor, it consists of atoms and electrons, and electrons will be in motion, random motion due to kinetic energy. They will be in random motion, not in one direction. Few electrons move from this end to that end and from this end to that end, and there is no net flow of charge from one end to the other end. The charge becomes equal as they move from that end to this end and this end to that end. Actual movement of charges in one direction is not there. This is because there is no potential difference. Now if you apply the potential difference, what will happen? If you apply the potential difference using a battery, this end will be positive and this end will be negative, then all the electrons will be moving in one direction. The reason is that it produces electric field inside the conductor. The voltage what we applied, it produces electric field. Electric field inside the conductor. Then the electrons start moving in a direction opposite to the direction of the electric field. Opposite to the direction of the electric field, electrons start moving. Because the reason is that charges present in an electric field will experience the force. The electrons experience the force. Hence, they start moving in one direction. All the electrons here inside the conductor start moving in one direction towards the positive end. All the electrons start moving in one direction. Hence, then there is a net flow of charge from one end to the other end. Electrons flow like this and supply of electrons takes place. Hence, there is a current. Hence, there is a current in a conductor. Now, this is how a current is constituted in a conductor. Now, what is current? The current is the rate of flow of charges. That is, I is equal to dq by dt. Rate of flow of charge. Or I is equal to q by t. If there is a steady current, then I is equal to q by t. Then the current is the ratio of the charge flown from one end to the other end, net charge flown to the time taken. This is how we will define the current. The SI unit of current is ampere. Ampere is the SI unit of current. As the electrons move from negative end to the positive end, in the opposite direction there will be a current. It is just a conventional direction. The current direction always be conventionally we took the direction of the current is opposite to the direction of the flow of electrons. Direction of flow of electrons. It is only the conventional direction actually. Anyway, I is equal to Q by T. The direction of the current is opposite to the direction of flow of electrons. Now this is how in the application of the potential difference, electrons all move in the same one direction due to the force experienced, and due to the force experienced all the electrons start moving in one direction, hence there is a